Hello and welcome to this eCognition Deconstructed video, and today we're going to have a look at the compute statistical value algorithm. What does it do? It performs a statistical operation on the feature distribution within a domain. That is important, so the domain plays an important role here and stores the result in a process variable. So what are the important parameters of this algorithm? First of all, the variable, right? Where you actually can select an existing variable, or you simply can create a new variable. And in this case, only scene variables can be used, so no object variables, for example. And yeah, it's gonna store the resulting value in this variable that you then can display, for example, in the image object information window, or that you can use as a threshold in your classification in a loop or whatever. Then operation is important, so you can compute different statistical values. I simply put here all of them, so number, sum, maximum, minimum, mean, standard deviation, median, quantile. And again, those are computing statistical values based on the domain, right? So the number counts the objects of the currently selected domain. If you select in the domain a certain class filter, or if you set a certain class filter, it will return the number of that class on that level on a certain map in a certain region, whatever your domain settings are. Then the sum returns the sum of the feature values from all objects of the selected domain. Maximum returns the maximum feature value, minimum the minimum feature value, and the mean feature value. That also makes sense. Standard deviation returns the standard deviation of the feature value of all objects of the selected domain. For the median, it actually takes all the feature values, puts them in a list, sorts them, and then takes the center value of that list, so that's the median. And for quantiles, you actually can define the percentage. So the quantile returns the feature value where a specified percentage of objects from the selected domain have a smaller feature value. So you can define here 20%, for example, and then it's going to return the feature value of that feature that you've selected based on the domain. And if this is, let's say, 1.2, then 20% of the objects that you have defined in the domain are below that feature value and 80% above that, right? I think that makes sense. And then of course the feature, that's the small last point here. You can select all features that eCognition provides, right, from the feature list. So also shape features, spectral features, standard deviation, object length, whatever. So all features are supported here. All right, let's have a look at eCognition and how you can use this algorithm to extract valuable information about your objects. I do have here RGB and near-infrared layers, an NDSM and NDVI, right? And I have vector layers which represents the outlines of the trees. And actually that information is based on project and rule set in our knowledge base, which is called tree crown delineation. So a very nice rule set and project where you extract trees based on a point cloud, more or less. Have a look at that one and then continue here watching this one. But we will continue here. Let me get back to RGB. And first of all, I want to create objects. So I'm quickly going to use the vector-based segmentation. Use my trees vector and create a new level. And then I want to classify, assign class by thematic layer. I want to classify or create classes based on information in a column in the attribute table. So look into my thematic layer trees. We have a column called class names. And then change this to create new class, and then it's going to create classes for all entries it finds in this column, and it's going to be one. Trees, right? That makes sense. So we have trees here. Each object here that is green represents a single tree. And now we can have a look at the compute statistical value. compute statistical value, right? And the statistical value is computed on the domain settings. So if we filter here for the trees, it will only compute the statistical values, or it only will include the objects that are here on this level. You can set conditions, you can define a map, you can define a region, and so on. And that also works on sub-objects, on lists, on vectors, right? So we also could perform this on a vector. I'm going to show you that here on objects, right? Because that's probably what you want to see and you're going to use in future. Now let's have a look at the parameters, variable, operation, and feature. Yeah, variable is going to be the output variable where this statistical value is going to be stored, and I'm going to create one. Okay, let's stay with minimum. I'm going to call it minimum height. Call it var for variable minimum height. And you can type in the name here, click somewhere in the window, and then it's gonna pop up here, this create variable interface. We wanna have a double. It's gonna be a scene value. All right, hit OK. And now it created this variable. Operation, you have the list here that I mentioned before. Let's start with the minimum, and we wanna have the minimum, for example, of the NDSM. So how high is the smallest tree in our scene? Hit execute, and there you have it, 1.3. And it might be interesting also to know the highest tree, right? So we change this to maximum. I am writing, you could overwrite this variable. I'm simply gonna create a new one. Maximum. Okay, so there you have it. Could be meters, could be feet. I would need to check that. Yeah, but there you have it. So, and that's the elevation, right? But you can actually use everything here. Mean NDVI, for example, which is the lowest and the VI value of a tree, and what is the maximum. Okay, maximum is 0.69 and the minimum is minus 0.13. So this is actually probably, you would need to look at this one. That's interesting. That's probably shadow, I think. I don't know if that the NDVI value is the layer is a good one. Oh, well, yeah, but you actually also could like navigate to that object using the image object table, for example. Let's open this one and double click, select classes. I want to have the trees and features, select the features. Yeah, let's check out this NDVI. There we go. Okay. And we have to display the image object level. And there you have all objects that are classified as tree. And we should have another column with the NDVI. And now we can actually sort it here in this list, in this table. And there we have this one. And if you select it, it zooms to that object. So a trick is to zoom in. And then it's gonna go directly there. Okay, so that might not be a tree. That's misclassified, right? So this is not a tree. So that also helps you to investigate your classification and your data set. Yeah, let's have a look at another one. Maybe maximum number. Trees. Okay. Okay, so this one is grayed out, so those two are not used, and that's going to return the number of trees object. So 1269. Okay, what else? Some, let's go for some NDSM that probably doesn't make sense. That's going to be a high value, right? That's the sum of the height. In this case, it doesn't make sense. Well, I mean, if you stack them, those 1,269 trees, you're gonna have a super tree which has a height of 25,238. Okay, let's have a look at another one. What else do we have? Whoops, so the mean is self-explaining, I guess. Median as well, standard deviation as well. Let's have a look at the quantile. The quantile parameter, right? This is a value range between 0 and 100. So 1 means 1%. Let's have a look at 5% maybe. Mean NDSM is the feature, and yeah, unit can be changed. In some cases it makes sense, in this case it doesn't. So I'm gonna change this. Quantile 5 height. Okay, it's a double. Execute. All right, so this is not a value, the feature value where 5% of the trees are below that and 95% are above this feature value. Okay, let's just go also for the mean. Some mean, yes. Where's the mean? Right, so the mean is roughly 20. And yeah, so you can get statistical values on your domain, and you also can use this for classification now, right? So you could classify every tree object that's below the mean, or use the quantiles as a threshold, right? So that is very helpful in classification and splitting up your classes, right? Based on statistical values. And yeah, the feature, you can choose the whole list here, right? Let's go for the median. Right, median is, it creates a list of all feature values and then takes the middle one, and we're simply gonna go now for the area. So you see that we also can use geometry features, right? Extend area. And you could use all of those features, right? Just to be clear. And here the unit comes into place. You can change it from pixels to, I'm gonna go for square meters because that makes sense to me. Okay, units is meters, and then it's gonna be square meters. That makes sense. Okay, but it might be feet though. So let's go for this one. Median area here. 29.25. Okay, so maybe displaying the NDSM just once in false color. Right, so those statistics might help you to improve your classification, right? To find outliers and stuff like that. To understand the distribution of the feature space of your domain, and also those statistical values simply can be used to for export, right? If you're interested in those statistical values, export them as a CSV file, as statistics, or append them to an attribute table of the vector, and so on. So a lot of possibilities there. All right, and I quickly want to show you how you can use these variables in classification, right, process. So first of all, also here in the feature view under variables and arrays, variables scene variables, you have all your variables that we have created. And now I'm simply going to use assign class. Class filter is trees. And now the condition is we're going to use the height. So the NDSM. If this is less or equal to one of our variables, let's go for the quantile. Hit OK. If this is true, put them into the class low. Whatever. Execute. And let's display the classification. So actually those might be tree objects that you might need to investigate a bit further because they fall under the 5% quantile. Yeah, check them out. Also our misclassified object is in there with the low NDVI value. And yep, that's how you can use those variables in your classification in the rule set. Right, so that's it for this video. I hope you enjoyed it. Thank you very much for watching and see you next time.